Welcome to One Question at a Time, the TSI series. Question number 49. A softball is tossed into the air upwards from the first floor balcony. The distance of the ball above ground at any time is given by the functions h of t equal 14 plus 32t minus 16t squared, where h of t is the height of the softball above the ground in feet and t is the time in seconds. What was the maximum height in feet of the softball above the ground after it was thrown? So the hint is the maximum height occurred at the vertex. Calculate the vertex. So we know that we see the given equations or function right here. It's the quadratic equations. If we set it to 0, so to find the vertex, we will have v equal hk, while h right here is the x value of x coordinate of the vertex, and to calculate that, it's the same as minus b over 2a. And to calculate k, we have to plug in, so we have h from the functions of minus b over 2a. To make it a little bit easier, let's say it's not that, let's say x and y, okay, x of vertex and y vertex, so it's not confusing, because we use later h for the functions, the given functions. So we will have ax squared plus bx plus c. This is the quadratic, left side of the quadratic equation. And the quadratic functions, we will have f of x equal that. Okay, so let's erase that right hand side to compare the functions only. We will have h of t that equal to, now the square term have to be right first, so t squared, that is negative 16t squared. Okay, now x terms will be 32t, t is x, f is h. Okay, so f 14. Now we compare and we have a in this case is negative 16, b in this case is 32, c is 14. And making sure you include the sign, okay? Making sure you include the signs in front of the the term, like the coefficient of t squared is negative 16. It's not 16 only, but negative 16. So include the number and the sign. So we have a is negative 16, b is 32, c is 14. Now we plug in the equations right here, the formula right here. Have x of v is minus 32 is b. This minus is come from the formula right here over 2a, so 2 times negative 16. And this one equal to negative 32 over negative 32, which is 1. Okay, so we will find this one we know this part right here is your x sub v. Okay, so the h right here is your y sub v. Okay, so h of 1 that equal to, plug in -16t squared. So instead of writing t, we have to open the parenthesis, make a parenthesis, so you can plug in the t value in there. So t squared plus 32t is multiplied by the parenthesis plus 14. Now t equal 1, so write that 1. This is t, okay, time, and if we know the coefficients will tell us the concavity. So if a is negative, less than 0, you have its concave down. So you have the vertex is right here, and is the maximum. If a is positive, you will have its concave down. I mean, it concave up, and then you will have like the minimum right here at the vertex. So we have the negative a in this case. So it will be have the maximum at the vertex. That's why we need to find the vertex. Okay. And t in this case, you can write down here is the t and comma h of t, just like x and y. Okay, that's why we plug in here. So we have this one equal -16 times 1 is -16 at 32 at 14. So we have -16 at 32 is 16 at 14. This is 30. So 30 feet. So the ball will touch 30 feet. We're at the 30 feet above the round after 1 second. That's what is the calculation mean. Okay. And here is the maximum height, that is 30. Yeah, it fall down after 1 second. Okay, 30 feet. This one, if they're asking for the unit, that's 30 feet. Basically, when we're reading the questions to solve for this problem, we only need some keywords here. Is the maximum height, okay, in feet. Okay, so what is the maximum height? They're asking for h of t. Okay, after how many seconds, then the ball will reach the top. Okay, so it's after first one right here. So then we move up, and right here is 30 feet. Okay, and it's through from 14 feet above the round. The round is 0. Okay, so the projectile is go from the balcony of the first floor, so it's 14 feet above the round. They throw it up. So after 1 second, okay, this is t. After 1 second, it will be touching the maximum, which is the vertex right here, and then we have 1 comma h of 1. Okay. So to find the maximum height, we have to find how much time they need to reach, the ball needs to reach the maximum positions. And we know that when t equal 1, you got the maximum based on the vertex formula of the quadratic equations or the quadratic functions. So we have, this is the formulas for x value of the vertex, and this one is for y. which is the one we need to find. Thank you for participating in this series and see you next time.